This is Bayes' theorem. Here it's expressed as an equation using mathematical notation. I've seen this equation hundreds of times and it never really does the trick for me. To really feel the essence of Bayes' theorem, what helps me is to read an interesting word problem or to watch an insightful YouTube video, of which there are many. But after tinkering around with some circles and Venn diagrams, I think I've come up with a pretty cool way to represent the equation more visually. So let's check it out. Here's the universe. So let's say the probability of event A is 0.1. Here's a yellow circle that takes up 10% of the surface area of our universe.
Kind of looks like an egg.
Now, let's say the probability of event B is 0.5. So here's a big blue circle that takes up 50% of the universe. Now that we've collected the base rates for the probability of A and the probability of B, let's clean the slate and introduce the first conditional probability. The data has been collected, and it appears that when A is true, there's a 90% chance that B is true also. Said another way, the probability of B given A is 0.9. Accordingly, we can see the green sliver takes up 90% of the yellow circle. And if we pull it all back together, we get something that looks like this egg with a puddle of water on it. But we're here to make Bayes' theorem look less boring. So let's take stock of the visual components that we have and see if we can plug them into our original equation. Let's clear out the numbers since the pictures are actually more important for my purposes. Next, if we assume that the universe is equivalent to 1, then we can remove the denominators on these base rates. So, let's pull up the equation and replace some letters with pictures. The probability of A is this yellow circle. The probability of B is this blue circle. The probability of B given A is this fraction here. And all that leaves us with is the left-hand side of the equation, the probability of A given B. Let's pull our wet egg back up once more to see how we would make this visual representation. So we're conditioning on B, so let's make that blue circle our denominator. And given that B is true, how often do we see A being true as well? Let's pull that intersection of A and B into the numerator. Let's add our letters back in for a quick reminder, and here it is. Bayes' theorem as a sort of visual equation, if you will. What I really like about this view is that it's really easy with just a touch of algebra to see that the left-hand side is equivalent to the right-hand side. Just look, if you cross out our yellow circles,
Well, that about speaks for itself. And yes, you could do this algebra with the letters themselves, but there's something nice about the pictures, in my opinion.
there's many ways to learn about Bayes' theorem. I've had the most success with learning about it repeatedly and from different perspectives. This is just one perspective I stumbled upon.